How the electric locomotive engine working? Ever watched a massive electric train glide by and wondered where it gets its incredible power? It doesn't carry a huge fuel tank like a diesel. Instead, it runs on pure electricity from miles away. But how does high-voltage wire power a set of spinning wheels? Today, we're breaking down the amazing engineering inside the modern electric locomotive, from the wire above to the wheels below. Let's get started. The journey begins on the roof with the pantograph. This is the train's arm that reaches up and maintains constant contact with the overhead line, catenary. This line carries extremely high voltage, often 25,000 volts AC. Once collected, the power immediately hits the first essential component, the circuit breaker. Think of this as the master safety switch. If there's a problem, it instantly isolates the locomotive from the high voltage, protecting all the equipment inside. 25,000 volts is far too high for the motors. That's where the heart of the loco comes in, the main transformer. It's a massive unit that steps down the high voltage to a much lower, usable voltage, typically around 1,000 to 1,500 volts. Now, modern trains use high-efficiency AC, alternating current traction motors, but the power collected from the wire is also AC. Why do we need more conversion? Because to control the speed and power of the motors, we need to precisely control their voltage and frequency. This is done in two stages. First, the rectifier converts the AC power into stable DC, direct current, power. Second, the inverter takes that DC and converts it back into three-phase AC power. But this time, the computer can precisely control the frequency and voltage. This perfectly tuned three-phase AC power is finally sent to the traction motors, which are typically mounted inside the bogie, the wheel assembly. The motor uses the principle of electromagnetism. The controlled current creates a powerful spinning magnetic field inside the motor, which pushes the rotor and, through the gearbox, spins the train's wheels. Each wheel set has its own powerful motor, allowing for thousands of horsepower to be distributed evenly across the locomotive, giving it the incredible starting power needed to move a train weighing thousands of tons. But the motor isn't just for moving forward. It's also a powerful brake. This is called regenerative braking. When the driver brakes, the motor switches roles from a user of power to a generator of power. The momentum of the train forces the motor to spin, converting the train's kinetic energy, motion, back into electrical energy. This saves massive amounts of energy and reduces wear on the mechanical brakes, a huge win for efficiency and maintenance. So, to recap, the pantograph collects 25 kilovolts. The transformer steps it down. The rectifier, inverter, makes it controllable. And the traction motors use electromagnetism to drive the wheels and even generate power when braking. It's a complete, interconnected power plant on wheels. Next time you see an electric locomotive, you'll know the complex, brilliant engineering quietly working beneath the skin. If you learned something new, hit that like button and subscribe for more engineering deep dives. See you next time.